I'm Andrew Anklam. I currently am a master's student at Michigan Technological University, but I've spent, before starting my master's, a lot of time working for the Forest Service and Park Service in the Minnesota DNR, primarily on industrial mining sites. And so today I'm going to be talking about utilizing the government land ordinance survey notes and a way to essentially recreate these notes in GIS to really target some of these very small prospecting ephemeral sites that are often nothing more than a small set of excavations. And I want to talk more about kind of at the end of this, how can we use this method for working with the early industrial landscape, or the eve of industrialization on these historical mining landscapes. This is kind of a spin-off of some of my master's thesis work. It's going to cover a bit of kind of the methodological way we went around about trying to identify some of these ephemeral mining sites out on IRL. And I'm kind of going to save the big picture stuff towards the end of it and really kind of summarize a lot of the method section. But I want to pose some questions to you at the end. I want to see what people have to say. And I should also introduce myself. I'm Andrew Anklam. I'm a master's student at Michigan Tech, but before I started at Michigan Tech, I worked for the Forest Service, Park Service, and Minnesota DNR. I worked a lot with industrial sites, specifically like mining and logging sites, and I had the chance to work with Seth DePasquale out in IRL in the past, and we kind of cooked up this research project. So during the 2020-2019 field season, archaeologists at IRL National Park set out to identify the location of several known but never field-confirmed exploratory mining sites. These sites are associated with the first mineral rush in the United States, creating the California gold rush by 5 years, and representing an early extractive resource frontier. All the sites targeted for the survey had been noted as part of the 1847-1848 Government Land Office survey. So by translating the original public land survey measurements in the survey notes and recreating them in GIS, coordinates for these sites were derived and surveyed. So the goal of the survey was to determine what the archaeological footprint of these ephemeral mining sites looked like and how it played into the development of IRL as a resource frontier. So the initial impetus for the survey was the addition of several sites noted during the 1847-1848 Public Land Survey, or the Government Land Office Survey. We're just going to refer to it as the GLO Survey from now on. So an addition of several of these sites into the Michigan State site files by the former Michigan SHPO. So initially, this GLO survey was targeted to verify and define the spatial boundaries of these unconfirmed SHPO sites, but they also included more sites noted in the 1847-1848 survey as they were identified while reviewing the notes. So unlike most of the ephemeral exploratory mining sites on the Keweenaw Peninsula, on the Upper Peninsula of Michigan, that occur concurrently with the exploratory mining on IRL, the sites on IRL have been left relatively undisturbed. So this gives us a window into the exploratory phase, this ephemeral exploratory phase of mining on the Keweenaw Peninsula that we couldn't get on the Keweenaw Peninsula because it's been largely built over and overshadowed by more successful later mines. So mines on IRL had to operate in a very unique location. And the island is located in northern Lake Superior near the Canadian border and is heavily forested with a boreal forest type. So most of the year, the island's frozen out and only allowing for a short 5-month season. 4 of those are completely infested with mosquitoes and biting flies. So there's a really famous quote from this University of Michigan researcher in 1868, and he compared the conditions in IRL to the 7th ring of hell in Dante's Inferno. So what makes IRL and the Keweenaw Peninsula really unique is they're comprised, the bedrock, so they share the same bedrock formation, but these bedrock formations have loads of like pure or native copper. So copper that's kind of in its natural state is already kind of usable and workable. So unlike other lodes of native copper elsewhere in the world, the quantities present on IRL and the Keweenaw Peninsula could actually be mined profitably. So long before Euro-Americans started mining copper on IRL, native copper had been mined by indigenous peoples. Pre-contact mining occurred mostly during the Archaic period, but continued up through contact. These pre-contact copper mines in IRL date back at least to 5,000 years before present, making them some of the oldest mines in the Western Hemisphere. And I love this picture up here in the top right, because each one of these people are standing in pits, and you stand on that location, it's just pits as far as you can see. So rumors of copper in the Lake Superior Basin had long been known to Euro-Americans. However, it was not until the state of Michigan's Geological Survey confirmed the presence of profitable quantities of copper in the Keweenaw Peninsula and IRL in the 1840s did serious attention start being paid to copper mining in the region. By the mid-1840s, the Lake Superior bands of Ojibwe ceded IRL as well as the rest of the mineral lands of the Keweenaw Peninsula to the United States. This legally opened up IRL to prospectors and miners, which had previously been home to the members of the Lake Superior bands of Ojibwe and the American Fur Company fisheries. So the rumors of the vast amounts of pure copper and rampant speculation immediately set off a rush to stake a claim on IRL in the Keweenaw Peninsula. The rush was aided by a mineral lands claim system imported from southwestern Wisconsin that allowed claimants to gain mineral rights at a low initial fee, followed by a government lien on future profits. Claimants started to rush the island as early as 1843, looking for veins of calcite charged with copper to stake a claim on. Most of these early claims failed as they had laid claim to unproductive lodes, and secure financial backing was hard to pin down. By the 1850s, most of the mining activity in IRL had died out due to a change in the mining lease system that required claimants to buy their land outright, the logistical burdens of operating on a remote island, and declining copper percentages in stamped ore. So during this initial speculative ephemeral rush phase on the island, several small-scale exploratory mines were formed and abandoned, with most lasting no more than one season. Two later phases of mining would occur on the island, with their successes overshadowing these earlier mines. So during the initial rush, the island had yet to be surveyed into the public land survey system. This, along with confusion between mineral land offices located in Copper Harbor, Michigan, Ontonagon, Michigan, and Washington, D.C., resulted in the same claim being issued to different people. So to remedy this confusion, the state of Michigan allotted money to survey IRL into the public land survey system. The public land survey system, which had been initiated as part of the Northwest Ordinance, allowed for a system dividing the land into discrete square mile units that could then be sold. This system of ordering allowed for the rationalization of land for settlement by Euro-Americans. On IRL, the public land survey began in the summer of 1847 and was conducted by William T. Ives, a veteran land surveyor. So Ives would begin his survey by starting his survey as close to section corners or corners of section lines as possible. Section lines are imaginary lines that separate townships into 36 square sections that are predetermined from an imaginary baseline. From the section corner, Ives would meander along the coast or section line, recording his direction in compass quadrants and distances in chains and links as he went. As Ives was surveying the land for eventual sale, he was instructed to note what type of timber the land had supported, the soil, and the structures he encountered. So hopefully this little slide here makes it kind of clear. I mean, I'm assuming a lot of us are familiar with the public land survey system. So because these structures that Ives noted have measurements associated with them, they can be translated and mapped to produce coordinates that can be entered into a GPS unit. The first step in this process is converting the measurements from chains, so one chain equals 66 feet, and links, so one link, there's 100 links in a chain. So converting those measurements into meters, and then taking the compass quadrants and then converting those into north azimuths. So with the measurements translated, they were then digitized and formatted so they can be read by the coordinate geometry or COGO tool in ArcMap. So the COGO tool reads the data akin to a CSV file with rows and columns representing the distance and directions of the survey measurements. Yeah, so once these measurements have been digitized and formatted, they're imported into the coordinate geometry tool. So the COGO tool, the coordinate geometry tool, takes the measurements that have been assigned to it and applies them to an empty feature or shapefile from a known starting point. So as the starting point for any public land survey system meander or section line is always a section corner, the noted starting section corner from the notes is selected as the starting point. So if the data loaded and the starting point selected, the traverse function, which is part of the COGO tool, will recreate the surveyor's paths. So GPS coordinates can then be derived from any point along this path, such as the location of a noted structure. So although these surveyor notes can be translated and mapped by hand, the chance of error is much higher. So mapping these notes in GIS remove the chance for small human errors, such as bumping the paper or moving your hand, that can cause erroneous results. So because the public land survey system was carried out in most places west of Ohio, this method can be applied in most places in the western United States. And I believe a lot of other countries also copied this method, so you apply them in other places as well. So I should note a form of this method has been carried out by Edward Gonzalez Tennant in his work down in Rosewood, Florida. However, his translations were done to reconstruct property boundaries using the meets and bounds system and not the public land survey system. And then I should also note Patrick Martin in the 80s kind of went out here and did a lot of the same things by drawing these out by hand. So I'm kind of really picking back up on the work that he did in the 80s. So just like field work done by Ives during the public land survey, the work on IRL remains very difficult. This is not only due to the remote location and dense vegetation, but its dependence on boats for transportation. Boating on Lake Superior, the largest freshwater lake on the world, is highly dependent on weather conditions. This means that even the best planned surveys are often cut short due to changing weather. So the crew for the 2019, 2020 GLO survey usually consisted of 3 crew members, which would beach the boat at or near the derived site location. So once on shore, the team will use a GPS unit loaded with the derived site location to navigate to the site. So once at these site locations, we conduct a pedestrian survey, usually at about 10 meters intervals, to identify possible features like foundational berms or diggings. If a feature was identified by the pedestrian survey, a metal detector survey was conducted to confirm the presence of metal and the existence of the site. If no features were identified by the pedestrian survey, a metal detector survey would be conducted over areas determined as like high potential for pedestrian survey. So as the metal detector hits are identified, they're mapped with pin flags and recorded with a GPS unit. So this helps determine the spatial extent and concentration of ferric materials at the site. Once the metal detect survey has been completed and the metal detects mapped in, we then selected 1 to 2 isolated metal detects to excavate with shovel test pits. So we kind of did this to avoid impacting, a cluster of metal detects that might represent like a feature or something like that. So we'd try to choose something that was off kind of on its own. And so we'd go about excavating these metal detects until we could determine essentially the age of the site, confirm its age with a diagnostic artifact. So once we had done this, no additional testing was done. So during the GLO survey, our field crew was able to visit 23 locations, made discoveries at 14 of them. So most of these identified sites relate to mining activities and represent a snapshot into the height of the copper rush and the systems behind it on IRL. And so, to do the quick math, that's approximately a 60% success rate with this method. And what's really been awesome about this is we've been able to kind of pull out sites that we had tried at for years and years and years and never been able to find, but then just dropped us right on top of it. So just for the purpose of this presentation and time limits, I'm only going to focus on one site, the Mott Island exploration sites. And I talk ad nauseum about all these sites, but I think for IA purposes. we're only going to talk about this site. So unlike a lot of the exploratory excavations on IRL, there's some historical documentation about the Mott Island explorations. This documentation suggests that these explorations are some of the earliest Euro-American mining on IRL and belong to the Siskiwit Mining Company. The explorations are described by Ives as approximately a kilometer from the southwest end of Mott Island and consist of a calcite vein that has been partially blasted and excavated. So a survey performed here in the 90s identified the site, but only located one feature. And the feature was not the one noted by Ives. So the 2020 survey re-identified the prospect pit found in the 90s and then located an additional prospect pit, a shaft of a related porrock pile, and a fissure excavation along a calcite vein. The next slide, I've kind of got some annotations so you can kind of see some of these features, right? This is the tiny shaft. There's a little porrock pile. There's this big prospect pit. It's not that deep. So we've kind of mapped it out here, but the calcite vein in the fissure matches the orientation and size of the calcite vein described by Ives and in other historical documents. This seems to corroborate that these excavations are some of the earliest on IRL. Considering this, it's interesting that Ives did not note additional features in his survey notes. No metal detecting was done here as the terrain was not conducive. Yeah, so Ives apparently really only mentions that there's been blasting along this calcite vein, and he doesn't mention this prospect pit or any of these other prospect pits or shafts. And I can kind of talk about that later, but so the archaeological footprint of this Mott Island exploration site was larger than what was noted in historical documents. It's likely that this increase in features is due to Ives not noting all the features present. You know, this description, we've noticed this discrepancy in Ives' notes and has been observed at other features in other historical documents. Another possibility is that some of these excavations postdated Ives' survey. However, no records point to renewed interest in this location. So out of the 9 locations where no features were identified, all appear to be described as claim locations by Ives. These claim locations tend to consist of a small cabin or shanty erected to hold a claim on a location while a claim paperwork is being filed. Historical documentation describes these cabins or shanties as small cabins as nothing more than crude lean-tos that were built with whatever material was available. These structures would have left little in the way of an identifiable archaeological footprint. This could also suggest that these claim cabins were set up on unproductive deposits and did not warrant significant investment of labor to prove the resource. So the goal of this GLO survey was to identify the scale of the archaeological footprint for the first phase of ephemeral mining in IRL. Previous archaeological investigations on proven mines from the first phase of mining, like the IRL and Ohio Mining Company, have identified extensive workings. It had been assumed that these unproven ephemeral mines had small or did not have expansive workings and left too little of an archaeological footprint to be identified. In contrast, the GLO survey was able to show that several of the ephemeral mining sites do leave a subtle but identifiable archaeological footprint that requires a precision survey to identify. Translating and mapping Ives' notes using the coordinate geometry method was able to provide the precision survey to identify these sites which had eluded previous archaeological survey. And so, yeah, so these numbers are a little bit old, but in some instances our point was literally on top of the feature, just to attest to the accuracy of these survey notes that were taken back in the 1840s. So archaeologically, the exploratory part of the mining process is difficult to identify. This is because successful exploratory mine sites are built over, while unsuccessful exploratory mine sites leave little readily identifiable features behind. The GLO survey provided the archaeologists at IRL and the Keweenaw Peninsula of a picture of what these ephemeral exploratory mine sites look like archaeologically. This survey determined that claim cabins or shanty locations have little to no identifiable archaeological footprint. And so this is where I'm going to kind of get into the bigger picture here, what we can use this method for, and I think what questions we should be asking ourselves from these GLO notes, and maybe getting a little bit into what my thesis is focused on. So although the GLO survey was focused on hard rock mining in the upper Great Lakes during the 1800s and 40s and 50s, The land survey processes and its context is contemporary with the placer-based California gold rush and other western rushes. The success demonstrated in IRL with the coordinate geometry method could prove useful in identifying and understanding other exploratory mining sites related to various rushes and mining resource frontiers throughout the western United States. And so kind of up in the corner here, I've got examples of the maps that were made from some of these survey notes. So this one is actually the Malakoff diggings, kind of as it was starting. You can see all these ditches and flumes here. These are constructed, for water movement purposes for placer mining. And then, here's, the image of Virginia City, but, we know a fair amount about what happened in Virginia City. But my question is, what about all these mills on the exterior or the prospect pits that dot the landscape here? And it doesn't really look like a lot of these pits are on these maps, but oftentimes I've found that what's not on the map is also reflected. They're talked about in the notes, but they don't really make it on the map. So just thinking like a landscape like Virginia City, what about all these prospect pits that are around the outside? What about all these places that didn't get developed? And so our understanding of IRL, like the first phase of mining, was really turned on its head from this, because we'd assumed there was a bunch of these mom and pop operations. But what ended up happening, what we ended up learning is that it was really just three of these big companies who had all these other tiny prospects out there, and that wasn't really represented in the historical records at all. So thanks for listening to my presentation. If you're interested in investigating this stuff at all, the Bureau of Land Management General Land Office holds all these records. They hold all the maps. They don't hold complete copies of the actual survey notes themselves. And those survey notes can often be gotten from the state archives. But sometimes they do have the associated survey notes, so you can do that. So yeah, that's my presentation. If you have any questions, I'd be happy to answer them. My master's thesis, kind of building off of this, is really looking at how did miners evaluate their claims? What was the process if they did that? And we can't really do that unless we had like this landscape data set that I was able to kind of derive from these methods.